Hello and welcome to Vision Academy. My name is Hanmant Ladwa and in this video we are going to write a C program to find whether the given number is an Armstrong number or not. So first of all, we'll just try to understand what do you mean by Armstrong number. For example, if I write a number that is 3-digit number, the sum of the cube of each digit of a given number is equal to the given number, then it is called Armstrong number. What is the meaning of this? Here you can see I have written 153. So if I separate each digit 1, 5 and 3, and if I make a cube of each of these three digits and add them, once again I'm going to get the same number. So such numbers are called Armstrong numbers. For example, 1 to the power 3 is 1 into 1 into 1 is 1 only, plus 5 to the power 3 is 5 5s are 25, 25 5s are 125, plus 3 to the power 3 is 3 into 3 into 3, 3 3s are 9, 9 3s are 27. When I add 125 plus 27, this gives us 152. 152 plus 1 is 153. So once again we are getting the same number here. So this type of number is called Armstrong number. Now we'll take one more number, that is 220. So if I separate each digit of this number and make a cube of each digit and perform the sum, whether we are going to get the same number or not, just check it out. So here 2 to the power 3 is 2 2s are 4, 4 2s are 8, plus this is also 8, plus 0 to the power 3 is 0. So this gives us 16, which is not equal to 220. So hence such numbers are called not an Armstrong number, right? So let us write the preprocessor directives. Hash include, in angular brace we'll write standard input output .h header file, and the next preprocessor directive is hash include, in angular brace we'll write conio.h, that is console input output .h header file. Now we'll write void main function curly open brace, and here I'm going to declare all the necessary variables with the data type int, and here I'm going to write n sum is equal to 0, and I'll take one more variable called num comma digit and put semicolon. So this num is used to initialize the value with n, because I want to keep the original value intact in this particular variable, and this digit is used to get the remainder after the modular division. Next we'll write CLR SCR function, which is used to clear the screen. Now we will ask the user to enter the number using printf statement. In a double quotation mark I'm going to write enter the number, end the double quotation mark and put semicolon, and we are going to receive the response from the user through keyboard using scanf statement. Here in a double quotation mark I'm going to write %t format specifier, put comma ampersand of n and semicolon. So as soon as you receive value for n, it has to be equated to one more variable called num. So num is equal to n value is equated to num. In order to keep the original value intact, we have to initialize. Next I'm going to use do while statement. Do is a keyword, it should be written in a lowercase letter only. Next curly open brace, that indicates this is the beginning of the body of the do while loop, right? Next I'm going to write digit is equal to n modular division by 10. So whenever we use modular division, it always returns us the remainder. Next I'm going to write sum is equal to sum plus I have to multiply digit 3 times. So that's the reason I'm going to write digit into digit into digit and semicolon. Next n is equal to n integer division by 10, and here I'm going to put curly closing brace and we'll write while. While is a keyword, it should be written in lowercase letter. Now I'm going to check the condition, n should not be equal to 0 and put semicolon. Now we are going to check the condition if sum is equal to num. So whatever the sum that we are going to get, if it is equal to the same original number, then it should print what? It is an Armstrong number. So here I'm going to write printf in a double quotation mark. I'll write it is an Armstrong number, end the double quotation mark and put semicolon. If it is not equal, then else part will have to get execute. Here I'm going to write printf statement, and here in a double quotation mark I'm going to write it is not an Armstrong number, end the double quotation mark and put semicolon. Here I'm going to write get ch function and next curly closing brace for main function. Now let us take an example. Here I'm going to write output, and this is the first run. So once we compile and run this program, it will ask the user to enter the number. Now I'm going to ask write 153 and press enter. So n is holding 153. Next, so this in turn initialized to num. Num is equal to n. N value is what? 153. 153 is initialized to num. Next, do, and here we are going to execute these three statements. Here the first statement is digit is equal to n is what? N is 153. Modular division by 10 always gives us the remainder 3. So 10 ones are 10, 15s are 150, and 3 is the remainder. Next statement, sum is equal to. So here sum for the first time it is set to 0, correct? So once it is set to 0, here I can write sum is 0 plus digit into digit into digit. So here I have to multiply 3 into 3 into 3. So it should give me 27 plus 0. 3 3s are 9, 9 3s are 27 plus 0. So this is 27. Now the third statement is n is equal to, n is what? 153, integer division by 10. So whenever we use integer division, it always returns us quotient. 10 ones are 10, 15s are. So it is going to return 15, right? Yes. So the first iteration is over. Again, before control transfers to do, it has to check this particular condition in a while. Here you can see n value is what now? 15. 15 is not equal to 0. Yes, it is true. Once again control transfers to do, and once again all these three set of statements will get executed. So I'm going to write digit is equal to n modular division by 10. What is the value of n now? Now it is 15. Modular division by 10. So this always gives us remainder, that is 10 ones are 10 ones are. So 5 is remaining. So this 5 will be stored in digit. Now we are going to perform the next statement. Sum is equal to, now sum value is what? 27. It is not 0 now. It is 27. So here I am going to write 27 plus digit into digit into digit. So digit is what now? That is 5. 5 into 5 into 5. So here you can simplify this one. 27 plus 5 into 5 into 5. 5 5s are 25. 25 5s are 125. 125 plus 27 is 152. Next, we are going to perform the third statement. N is equal to, n is 15, integer division by 10. So this gives us 1, correct? Because 10 ones are 10 ones are. Quotient is 1. So second iteration is over, and we are going to check the condition. Now n is 1. 1 is not equal to 0. Hence it is true. Once again control transfers to do, and it is going to execute these three statements. Here I am going to write digit is equal to, now n value is 1, modular division by 10. So as per the basic mathematical rule, when the numerator is less than denominator, then the numerator acts as a remainder and quotient becomes 0. So here 1 is taken as a remainder over here. Next, we are going to write sum is equal to, sum is what? Sum is 152 now. So 152 plus digit into digit into digit. Digit is what? 1. 1 into 1 into 1. So 1 into 1 into 1 is 1 ones are 1, 1 ones are 1. 1 plus 152 is 153 will be stored in sum. Next, third instruction is n is equal to, n value is what? 1 and integer division by 10. So here 1 is remainder and quotient becomes 0. So here quotient is 0. So third iteration is over. Here we are going to check this condition. N is what? 0. 0 not equal to 0? No, it is equal to 0. So this condition fails. Once the condition fails, the control never goes back once again to do. So it is going to execute the next statement. Here it is going to check if sum is equal to num. So what is sum? 153. What is num? 153. So both of these two are equal. Hence it is true. Once it is true, then this particular statement will get executed. What it is going to print? It is an Armstrong number. So it is an Armstrong number. Yes. So for else part, we are going to check out by putting some other number, and let us execute this program. For that, I will take you to laptop screen. Here you can see I have already written this program in Turbo C++ compiler to save your time, and let us compile this program by pressing Alt F9. Here it is showing success. That means there is no syntax error. I'll press enter. Now let us run this program by pressing Ctrl F9. Here it is asking the user to enter the number. For example, I'm going to enter 153 and then press enter. Now it is printing it is an Armstrong number. Now one more time we are going to run this program by pressing Ctrl F9, and now I'm going to enter number 220. Now it is printing it is not an Armstrong number. Now I would like to give you one homework. Please tell me how many 3-digit numbers lies between 100 to 999 are Armstrong numbers. Please write down your answer in the comment box. I hope you understood this program. If so, please write down as understood. Thank you.